Hi, Kevin.
Hi, how are you?
Fine. More or less. It's dark over here already.
Yeah, same here.
Finland. Yeah, but surviving this time of the year.
Yeah. What time does it actually get dark?
I don't know, around 4 probably. So it's already dark, like 1 hour or something like that.
Yeah, it's just getting dark now, and it's 4 here, so it's the same.
Good evening, good afternoon to everyone.
Hello.
So I would suggest let's wait a couple of more minutes for others to join. And meanwhile, I'll prepare a document for notes. For agenda today, Ed, you wanted to talk about prototype of device plugin, right? Anything else?
Well, actually, not just me, Christian as well. So I will talk about the plugin, and Christian will talk about this NRI plugin. So we will demonstrate the whole workflow, like from the device plugin till the like running workload with all injected, with modified spec, basically.
Anything else? Any other topic for today? Kevin, did Patrick submitted already a proposal for KubeCon?
I haven't heard a definitive yes or no from him. I put my bio up in there, and the text looks good enough for me now. So yeah, I don't know if he actually submitted. My guess is no, because when you fill in a co-speaker's info, you have to put in like previous talk experience and all that, and he never asked me what that was. So
hello, guys. Sorry for being late.
Christian, something wrong with your
Zoom, just a second. Is it better?
No. It's too loud and
doesn't use my headset. Just a second.
Better?
Oh, now it's a lot better. Great. All right, so gentlemen, Ed, Christian, the stage is yours. I think you have a main topic for today.
Okay, so just briefly about what we are going to demonstrate. it's an integration, like possible way of integrate CDI into Kubernetes environment. So basically, how we did it, we implemented it in two places. Like first, we implemented device plugin, and that plugin basically just scans all these CDI JSON files in etc CDI or like whatever directory like user puts it. And then if device is present on this node, it kind of picks it up and passes it to Kubernetes. So the workload, then we can specify like this CDY device as any other device. And then another thing that device plugin does, it sets the annotation, and it also okay, I will probably show. It would be faster to show. So this is how like the result looks. So we have
you are
two
not
devices.
showing.
Yeah.
Sorry.
Let me share my screen. So do you see it?
Yep. Terminal.
Yeah. Okay. So like this is a described node output. kubectl described node. So we can see like this, like two devices.
Ed, may I ask very first thing? Yep. So do you understand correctly what you did it in a way what any type of CDI files what is discovered, it's announced by this device plugin?
If device they are referring to is present on the system. So let me show it, like how it actually looks here. So we have kind of three devices. And then like loop one, which is basically dev loop one device. And we also like set up environment variables for them, and we expect to see it like in the container. And we bin mount like some binary. So I just I have chosen this echo
good.
like
good
to
example.
like as a vendor binary. And we also introduce one hook, which is basically just touches some file in TMP directory, just for the sake of simplicity. But that should be enough to like if we will be able to see environment variables and like this file and the binary in the like in the container. So that should be it. So that should be a good result of this. So this is the first file. The second one, I think it's TTI 10. So I will not be using it, but it's also like this device is also present, and Christian probably will show this part. And the third one, the device doesn't exist. So basically, out of these three devices, three CDI files, we see that the plugin basically picked up only two, like which exist on the system, and Kubernetes is able to see them as like resources. So
I wonder why so strange name. Why CDI / why it's announced like that?
Well, it's just proof of concept plugin. I don't know which name actually to pick up. So
I was just thinking like we already have like the vendor / class / device approach in the CDI. So okay, but yeah, it doesn't really matter. Okay, sorry.
It was some problem with this, some naming probably. I don't know. I as far as I remember, I tried this approach, but it somehow didn't work. I can try again. So this is the output of the plugin. And the thing I would like to show here on the screen is the annotations. So like this is annotation set for the like first device, and the so basically it's the same. It's for loop 1 device. So basically this is a key, like vendor loop. So all this information is coming from the JSON file. So loop is the name of the device, and this is a vendor 1 con. And this is a value. So this value is just a value to, like we set it just to be able to get this annotation on the container D side and understand that this is a CDI device. So that can be like anything. So that's this part, and then we have like this simple workload. So basically, it's like Ubuntu image like sleeping. So, and what we are going to do is, and it's requesting the device. So we are going to run it and then just exec into the into the container and see if what we expect there is there, basically. So, and last thing I will show before actually letting Christian to continue is the spec. So how it looks in the spec. Let's run it, and then so I just hacked the container D like really quick. So the Christian will show the proper solution, which is like an RI plugin, but my is just like I just put like code to parse the annotation and patch the spec. So I will not show the result, but the just a log. So this is a let me see. So this is basically the incoming spec. So on the container G side. So this is annotation we've got. So you see like bunch of Kubernetes annotations and our annotation is provided by the plugin. And then we'll see the device provided by the plugin. Should be somewhere here. Yep. So we actually we did it like through annotations, but we also tried to pass it like as a pass, just to see if Kubernetes would complain about it, and it didn't. So it just got through. So that's the thing, and then after applying like on like this JSON file, this is a result spec. So we here we should see like all these pieces that came, like hook, for example, that came from that JSON file. You can see this bind mount and the device itself should be.
It's below it. It's on the bottom.
Let's see. Yeah. So yeah, Linux resources and device here. So
Can I ask a quick question?
Yep, sure.
So if we've figured out a way to do it as an NRI plugin, and you are able to actually pass this information through annotations and not have to do it this hacky way through the host path, what's stopping us from supporting this today? It doesn't sound like there's any modifications that would need to be made to Kubernetes or Containerd at this point. Is that correct?
So
Yeah, you're correct. So nothing actually prevents us from doing it except of the container deep part. So like I just hacked it, so that thing is not going to be accepted. So I tried to like go simple way, and the container maintainers basically well they were hesitating to take it as is, so like this simple way, and they were referring to this NRI approach, which
But it sounds like Christian's figured out a way to do that.
Yeah. So, but
yeah.
Kevin, so the thing is that so we do it with NRI, but we do it with our proposed extensions
with
to
your
NRI.
extensions. Okay, yeah, I finally actually.
So that is the.
I got the chance today to actually look more into NRI, and I looked through your extensions and watched.
Okay, that's great. So if you have any feedback, please.
Yeah, it makes a little. The one really quick feedback I have, independent of your extensions, are why did NRI have a single invoke call with states instead of just multiple functions for each of the possible?
I don't know. So I think that they were, so to be honest, I think they tried to somehow model it after hooks and simplify it to hack it. So the whole implementation looks to me that it was really quickly hacked in by somebody.
Yeah, there's not a lot to it.
No.
It's not properly abstracted.
Yeah. And if you look at the implementation, so what happens in containerd, so whatever is written by NRI is ignored. So only the side effects remain in effect. So what you do outside in the plugin, that remains in effect. And what you return from the plugin is explicitly ignored. So it's really, I think it's really a prototype. So, but I don't know, because I tried to reach out for Michael Crosby and I have had a really hard time, basically. I think he's busy with something horrible. I just couldn't. So we initially had a discussion with him where we described what we would like to do. And he told that, okay, go ahead. I understand what you try to do and why you try to do it, and let's prototype something and then let's take a look at it. But that was a year ago. After that, I have been unable to really grab him for a
okay. Yeah, well, let's continue with the demo. I was just curious. So if your extensions get accepted to NRI, there's nothing that would need to change in containerd except, I guess,
enable plugins.
Would containerd need to be updated to then call out to NRI at more integration?
Well, I have that, so I will demonstrate also that.
So that's part of
demo about.
Yep.
Yeah.
Well, let me finish just like real quick, and then Christian will continue. So like just to like show that everything is in place, so we can just exec into the container and see that like device is there, and the actually the UID and like and group ID are like those that we mentioned in the JSON file, and then we can see like this timestamp from the hook, and we can see vendor binary, and we can even run it like because it's like echo basically. So we can run it and see the output, and we can see the two variables. So that's it. So it works. So that's end of my part.
And all your hack into containerd was to inspect the annotations and then
do injection.
Do injection, and there is one like tricky thing. We also have to like remove the device, because it's coming from Kubernetes, like the device, but we are not we don't want it to be in the spec. We actually want it to come from the JSON file. So we have to remove it. So that's it.
Yeah. Well, you remove it because if your plugin didn't ever actually insert it, then you wouldn't have it there, right?
Yeah.
Or do you have to have something? I don't remember how the plugin works. Do you
have well, I just don't want to see the duplicate. So I want like this device to come from JSON file, not from Kubernetes. And Kubernetes is just a way to provide the annotation and
no, Ed, what Kevin is saying is what in allocate response you filled the device part.
But you didn't
have
structure
because it's device plugin. So
yeah, but you can try to avoid it.
Leave it the annotations there. Yeah. and nothing
Only
in the device spec.
annotation. Ah, okay. And device part would be.
Device spec, just leave empty.
Yeah. That makes sense. I will try to do it. Thanks. Okay, so I'm done.
And it should work, just to be clear, because I know in the case of the GPU plugin from NVIDIA, we don't set the device spec. We only set environment variables. So
Okay.
It should work with just annotation.
I just okay. So I will let Christian continue, please.
Okay. So let me try to share my maybe this the whole screen. So do you see my screen?
Mhm.
So can you make it out what it says? Or because for me, Ed's font was a little bit small. So can you see the fonts also?
It's a little small, but I can read it. It's fine.
Okay.
If you can bump it at least like 1 point up. Because for me, anti-aliasing is make it almost unreadable.
Is it better or worse?
Oh, now it's better, a lot better.
Better.
Thanks.
Okay. So basically what I would like to demonstrate is basically that how this whole thing works then if the information that is injected by Ed's CDI device plugin is taken or consumed by an NRI plugin in containerd, and that NRI plugin is, so we had already a CDI injector or resolver plugin, which was, I updated it today so that now it works based on this information that Ed showed you. So basically annotations. So I have containerd running here on the top left side. I have CDI device plugin running in this top right. I will start the CDI resolver, which is the one which does this whole thing here. And then I have basically the same slightly modified CDI specs from Ed. So I have this, I changed it so that so it's better demonstrates the CDI capabilities that basically you can have a device context injection and then you have the global context injection, and when you do it, then both should show up. But those are just minor changes. And then I have a test CDI test spec, which looks like this. So it's very, very similar to what Ed did. So basically I have an echo or a sleep, sorry. And then, so a container which just sleeps and then it asks for CPU memory and for one of these CDI vendor2.com TTY10. So the same setup that Ed had. So let's see what happens if I apply it here. Okay, so basically the NRI plugin gets all the information. So here you can see the OCI spec that we got as input.
This is the input to the NRI plugin.
Yeah. Mm-hmm. And then the NRI plugin basically should dump what it, so it found annotated CDI devices vendor2.com TTY10, so only one. Then it went through basically the CDI devices and because this is not a properly formulated, fully qualified name, so it needed to match it. Ideally, we would have here directly in my opinion, this vendor2.com device equals TTY10, which is a uniquely identifying the device. That's what we should get there. But it disambiguated it to that one because that was the only one it matched, and then it injected. So it shows this is the container adjustment is basically is this one injected into an empty OCI spec. So this is what, so you can see that the environment variables are getting injected, the hooks are getting injected. Then we remove the device that had injected because I don't want, so like it also, yeah. Now it's injected, but it should not be there. So once he removes that, then this will not be necessary. And then we inject the real device, mounts, and so forth. And now if we check what we have, so we have TTY10. Basically, you see that with the same information that he showed, it's there, and we do not have this device. So this injection that was removed, this /vendor2.com, this TTY10. And then if we take a look at the environment, so we see that both of these environment variables are present. So basically everything got injected there. There is one more thing I can show you. So this is how I was using. So in the CDI pending PR that we have, so we have this command line CDI tool. I just want to show you that what was the idea with that. This is actually how I used it when I wanted to see what should happen.
Christian, one second.
Okay.
The TMP directory, like the hook injection, did it also work out
Yes,
properly?
I can show you. Let's see. So it should be, it touched something.
Yeah, it should be in TMP.
TMP start TTY10.
Yeah.
No, it's on the host.
It should be on the host. Yeah.
It's not on the host, it's here.
But the hook
Then
should
it depends on which hook.
It's start, container start or something like that.
Well,
you can
okay,
see it in
well,
the
It's
JSON.
Start
on the- it's
container,
on
you
the
can see it
over there,
here,
start
hook start
container.
container. So it's running inside.
Inside the
Okay.
container.
Yeah.
Yeah, so
If it
it's
would have
it's
been
example of LD config.
Yeah. If
Yeah.
I change it, if you want, I can change it to press start, and then I
No,
think that
No, it makes sense. It's just a matter
That's
of
fine.
did it inject it or
Yeah,
did
yeah.
it work?
yes, it did. And also so is in bean there should be the mount. So this vendor bean TT-item is also there.
Mhm.
So I mean, basically, in principle, everything.
I guess the main reason this requires your extensions is that because this is a modification to the OCI spec in general, I guess that has to happen before container start. And from what I remember reading about NRI as it currently is, that happens between create and start. Is that
Or
correct?
actually during create, it should happen. Because the thing is that, so once the container has been created.
Sorry, yes, during create this needs to happen. But
Yes,
but in the
exactly.
existing NRI, it's after create is finished that you get the hooks. Or not the hooks, but
Actually, I'm not even
callbacks
sure.
and
I read the original, maybe.
Mhm.
To be honest, I'm not. I don't remember. I don't recall now by heart. I can check from the code. It's. I don't know, to be
Yeah,
honest.
it's what the README said at least. I didn't.
Yeah. Yeah. Okay. Okay. Then it's like that. Plus, it is so that no matter what is returned currently from the NRI plugin, so container the implementation just ignores it. So you can do things, sort of extra container the actions you can perform in the plugin itself, and those of course have an effect. But the information that you return, at least the last time I checked the code, it was just ignored. So the return result is assigned to the underscore go variable. So basically it's getting immediately garbage collected.
Mhm.
So because it's a sort of prototype. So also that one it's not really a full implementation yet.
And what's the status of it? It sounds like, you said you've been trying to reach out to Michael Crosby for a year and he hasn't really been answering. Like, because I watched just today finally the presentations and wrapped my head around how it, works for the most part. But is there still buzz around doing it, like amongst people in the Container D community, or is it just kind of this thing that's not been talked about in a long time?
No. So if you look at the repo, basically most of the commits are this kind of CVEs to dependent packages being updated. So I mean, most like grunt work of keeping it so that it doesn't show up red on somebody's danger list or something like that. So I have not seen real.
Okay, so part of this effort will probably be also rebooting is the wrong word, but getting support around NRI in general for Container D again, independent of us getting the CDI plugin ready for it. So, but I think it was Ed that said that, with your PR against Container D directly, the feedback was you should just implement this in NRI. Is that what I remembered you saying?
Yes. First of all, Mike asked me to actually mention NRI in that PR. So I mentioned that NRI is like alternative solution. So, but it's kind of longer term. And the reviewer, it was just one reviewer, I don't remember his name. He was kind of pointing out to that, and it's like, so why are you proposing this? Because like if it's possible to do like with NRI. So, and
It was Akihiro who was saying that.
yeah, yes.
But
So,
Kevin, the latest status of it is what last week we joined the Containerd community meeting, like we were preparing for 1.6 release, and we mentioned about those PRs what we have, like both CDI and NRI. Unfortunately, Crosby was not participating on that meeting, but at least our maintainers promised to have a look. So the biggest problem in Containerd is what, like, there are several active maintainers, but the area what we are touching is require attention from the people who are not very active.
I see.
Or they are busy with something really.
Or busy with something,
and I think
yes.
that the whole Containerd community currently is really busy with their imminent release, which is supposed to come early next year. So I understand that they are really busy now with that. But we were promised that on the 13th of January, in the next community meeting, one of the main topics will be NRI. And I think that Crosby will find the time.
Yeah, I mean, from finally looking at it today, conceptually, it makes a lot of sense, right? Because Containerd doesn't have to do much in the sense of, like, you know, they put some code in there to call out to this plugin system that does a bunch of stuff on its behalf. And then you can have a bunch of third-party plugins doing these things instead of integrating that into the core of Containerd itself. So if they can get that part right, it feels like that would be a big win for them, because then we can start doing a whole bunch of custom stuff in the plugin.
That's the whole intention. And one of the examples what Christian had as a plugins. So like Cryo, we have custom things like injecting the OCI level hooks. And Christian, what was else? Some CPU management.
Yeah, they have some, so migrating basically interrupts of the CPUs for guaranteed containers and this kind of really custom stuff, which are currently directly built into Cryo. And the Cryo guys were saying that, hey, if we can split those out as NRI hooks or NRI plugins, then they are all for it.
Yeah, and even things, Sasha, which you've mentioned over and over again, I finally didn't wrap my head around until today when I looked into this, you know, re-implementing or having an alternative to the CPU manager in the kubelet. This is the perfect place to do that, because as long as all the information gets passed down into this component, it should have full knowledge of how to do that. The only thing I don't know how you would do exactly the same as the CPU manager is, it wasn't clear to me how you'd say that this, you know, in Kubernetes terminology, this container, this pod should have an exclusive set of CPUs, whereas this other one doesn't, right? Because right now that's all inferred from, if you have the CPU manager on and you set request equal to limit, and it's a whole number of CPUs, which is, you know, admittedly an awkward interface for it. But
right now we're doing exactly the same thing. So we detect the class, like implied class of service for containers, and when recalculating back from CRI messages what is used.
And then any containers that have been, instead of any containers that have been started by the kubelet, now it's any containers started by the runtime that don't have that matching exactly will be put in this, you know, CPU manager terminology terms, in the default CPU set that doesn't have exclusive CPUs.
That's true, but also we can like you still specify like the quota, you still specify the limits one way or another. If you don't specify, it will be best effort, and in case of best effort, well, it will end up somewhere in some zone. You don't specify, you don't know where it will end up.
Sure. In your implementation, I'm just trying to think, if we were to try and do one-to-one parity with what the CPU manager looks like today, you could have two bins. One is everything else, and one is this container has its own exclusive set of CPUs, and you could fully implement that. It's just the difference would be that difference would be it's not every container started by Kubernetes, it's every container started by this runtime.
Yeah. And actually, Kevin, there is one more step which is not part of the current NRI, but what I have, well, vision probably a strong word, but the idea what I have is what instead of kubelet trying to discover the resources and trying to manage like C groups or whatever else kubelet has, all of this should be done in the runtime. So kubelet should only tell what needs to be run.
Yeah,
and
this is
how it should be in
the
runtime.
what versus how.
Yeah, and this also applies to well, practically it even applies to the CFS quota calculation, because the current Linux CRI interface is actually, it assumes what the containers are run like normal Linux containers, and the quota is managed by CFS. But if we take the kata, and if we take like VM, so the CFS values inside the VM, it might be different what is outside. I think kata have some workarounds for that, but again, it's not really good design, I would say.
Yeah, I think that makes a lot of sense. The what versus how. Like a prime example of that is what someone wants is, 100 milliseconds of CPU, but I don't care if that's implemented with C groups if there's some other way that the system underneath happens.
Exactly.
Right?
Exactly. But that also applies to a bunch of other stuff, like with huge pages. So the kubelet assumes what, like with huge pages, like if container stops and it was using the huge TLB, then it will be promoted to the upper level limits. So kubelet does the different tricks for the pod level C groups settings for the huge pages, and that's nonsense, I would say. And then similar thing like the whole discovery of the resources. So the kubelet uses CAdvisor API to discover what is possible, but when it calculates, saying like I have this amount of cores, this amount of memory. But when runtime, it has some parent C group from which it consumes the resources. And this like settings on this C group might be different. Like, for example, like some CPU cores might not be available in this CPU set, or some memory limit, like upper limit for the whole hierarchy might be limited for some reasons. So these assumptions, it's hard to break.
Yeah. Yeah.
And then like it's like step by step.
Yeah, I mean the separation makes a lot of sense though. I like the way you put it with what versus how. But there's so many things integrated into Kubernetes itself. It's like you're saying, it's really hard to kind of twist that out of it.
One of the biggest problems what we have, and what I really hope we will have at some point solved. So in our project in CRIRM, we have a functionality to have a container and pod affinity and anti-affinity. So for example, like don't run Logger in the same resource zone with your, let's say, like training or some like mission critical application or something similar. So we implemented that using annotations, but ideally it should be similar syntax what we have for affinity inside pod spec. So to make it like first class citizen in the pod spec, to describe what is affinity and anti-affinity between the pods and containers within pod.
Yeah, makes sense.
But for that piece, I think for people, it's a bit harder to wrap a head about it, because people get used to well, topology manager policy. So like one policy for the whole node.
Even some of the stuff we're talking about here with pushing the CPU, handing out exclusive CPUs to a container is already, at least it's different. It's like I'm thinking about how we use Kubernetes in NVIDIA, for example. People assume the runtime's just kind of there, and all tweaks they do are done to Kubernetes. They don't do tweaks at two levels, right? They don't install plugins for the runtime and set settings up in Kubernetes. They can do all those things just from Kubernetes. And it's, at least from a system admin perspective, internally, I can already see it raising a bunch of alarms. Like now I've got to configure something down there too.
Well, on some degree, people already, like admins already teach about how to configure the low parts. like think about like if you want to deploy gvisor or something similar.
Yeah, no, I
You
mean, I get it.
still-
I understand. I'm just trying to, I still think this is worthwhile and this is the direction we should move. It's just making sure that we have a good way of
how to present it.
how to
So I
present
think
it
we should
and how
present
to
it as
get-
an alternative. So because to be
Mhm.
honest, so I think we would need to try this out on a larger scale, but to be able to do this, we would need to enable this infrastructure. And I think that the best sales pitch for this would be that we let people basically try it out and maybe plug in their own policies. And then I would expect, for instance, the operators to really get the aha feeling, because we know from day one that this is what they wanted to do.
Yeah.
So I think, so I have nothing against the current policies that are in kubelet, but those are limited. What I have something against is that why to have only those, and why not open up the infrastructure so that we can do something more flexible,
Right.
and then try out how that where and how that leads us, and then see whether we need to depreciate one or whether this is a bad idea for some other reason. I mean, it also might turn out, but it's best to try it out in practice.
Yeah, that's fair. What would be nice is just thinking about if NRI as it grows, it'd be nice to have an easy way to install these plugins instead of just taking a binary and popping it in the directory.
So
for us, it's just like daemon set.
So we designed the whole thing so that those can be
Okay.
deployed using the Kubernetes infrastructure itself.
Got it. Yeah, I
So
haven't seen
it's
that.
a daemon set. You deploy it to the node. It connects to a runtime socket. That's it.
Mhm. That makes sense. And you can tell it which ones you want to deploy and which ones not. And then, yeah,
And you control to which node, which plugins you're deploying.
makes sense. Yeah, that's the right way to do it. Yeah. So it's also kind of a Kubernetes managed installation of these plugins.
Yeah, and in protocol, what is part of Christian's PR is like we have this idea of reconciliation loop. So like once the plugin installed and when it's first time connects, it gets the whole information about the whole system. So it can see what like, yeah, I was deployed on the clean node where containers already somehow running. Okay, let's reshuffle them according to the policies what I have. So like update with like CPUs, update with memory allocations and so on if needed.
Got it. Yeah, so after they're deployed, it's able to, because yeah, there's like a chicken and egg problem there if you don't reconcile it. Yeah.
It doesn't assume itself to be the first content to be put.
Right.
Because that would be a limitation, huge limitation.
Well, there are still limitations. So for example, if you promising to, well, like good example, CDI injection. If you already have a running container, you can't inject afterwards devices. But again, maybe in the future it will be solvable because this limitation comes from current RunC, or well, let's say OCI runtime specification. What update mechanism doesn't allow you to add new device. But if in the future will be extended when we can inject also devices to already running container, it's doable.
Yeah. Yeah, you just jump into the mount namespace, put one in there, and then you jump back out.
There is also you need to update the C groups outside of container.
Yeah.
But again, it's implementation of RunC or well OCI runtime. Right now, update mechanism doesn't support it, but can be done.
Mm-hmm.
All right, gentlemen. We diverged a bit. It's actually a good discussion, but we diverged. So with this prototype, what we are doing and what's the plan?
I was going to actually ask this question. So like we are waiting for NRI, or we are trying to push for like this direct core modification. Are we going to touch kubelet in any way? Like, for example, to pass?
I think as long as it goes through annotations and it's not through this host path kind of hack thing, I don't think we need to. Annotation should be fine as long as it's not something passed from the pod spec through an annotation. coming from
Yeah,
fine. Yeah.
I second that. So let's not touch kubelet in that respect at this moment. So where we need to touch kubelet is this proposal for the dynamic resource allocation, what Patrick having.
Yes, yeah. But yeah, it's, to me, it sounds like the next big step is we need to get people excited about and you know, working on NRI again.
So with NRI, as Christian said, in January, we will have containerd meeting. So Kevin, if you can
Yeah,
join
I would
that,
love to join that. Can you just send me the information about it so I can?
yes. For core modifications, I think we can propose it if NRI will go longer. On cryo side, I think all the guys are on our side. I mean,
well, then
if you propose direct injection, or if you propose NRI for them, it's not a big deal to accept either of those. It's just like our groundwork to prepare the pull request and prepare tests.
Is that then it could just be used by all of these guys, right?
Yeah.
Yes, yes. Well, that's the whole idea of NRI.
Just like CNI, yeah. Okay.
So we are waiting for containerd meeting in January, or like anything we can do while we're
The
waiting.
CDI bits. How about the CDI bits? Because we have been sort of revisiting the CDI API, fixing bugs, and then basically.
I haven't commented on your PR today. I haven't looked at it yet, but he called me out in it, so
Yeah,
look at it in the next couple of days.
Okay.
What were we gonna say? Sorry, I cut you off.
Nothing. So I just wanted to say exactly that. I mean, that is something that we can, I think, push forward. So we just need to review it, and once we agree that okay, it's good enough to sort of merge that PR, I think that would be nice to get out of the door, because that is in a way independent of, or that is something that we fully control. We don't need to wait for anybody on that. Just need to agree with among ourselves.
Well, I would merge it right away, because it's much better than what we had, like what we have currently. So that implementation has like a lot of bugs and it doesn't cache anything. And we actually tried this.
Is a little bit awkward, I think.
Yeah, and we tried this new implementation, like Christian implementation. I tried it to work with it in the plugin, in the device plugin, and Christian was using it in NRI plugin. So it's well tested, and it's covered by the unit test as well. So it's like from any point of view, I can imagine it's much better than what we have. So we should just go and merge it.
Can we just walk through it real quick in these next 10 minutes?
Sure. If you guys have time, then yeah.
Is there anything else on the agenda, or?
No, we don't have anything else on the agenda. The main part was this prototype, what Adam Christian had.
So actually, so one thing that I could do is, since I'm still sharing my screen, I think something like this I could try to do.
I think one thing that would help too with maybe getting, I'm just trying to think ahead to this meeting where we're going to try and say like, hey guys, we really want NRI, working so that we can start building stuff on top of it. If we actually had that's great to have these demos with like loop devices and TTY devices, but if we actually had something more realistic, I think that helps sell it a bit better.
Yeah. So, and I think that on that front, so the NRI bits are easier than the containerd bits. And I think that the cryo guys are easier too. So I think that if we could get the NRI bits A-OK by Crosby and the rest, that, hey, these are fine changes. Let's just sort out all the remaining problems, write the necessary test cases, everything so that it's properly, we're sure that it works. then I think we could go pretty quickly or quicker on this on the cryo front and get that support into cryo. And on the containerd side, we also have this extra wish, which is both on our side and the containerd side, that we would like to. The current demo is it's like NRI, so it's a CRI plugin level thing. But they've had this wish that, hey, could we make it so that it would cover also Docker and CTR initiated containers, which makes sense, but putting that into place is so it requires more work. It's a little more difficult.
I missed that last point.
So Kevin, let me rephrase what Christian says. The containerd has multiple interfaces how container can be started. So CRI is one protocol, but when you have a containerd normal socket where CTR is starting the things, when there is a NERD CTL, which is also a bit different interface, and when we have Mobi for the Docker.
Yeah, I'm familiar with all of that.
Yes, and the thing is, what right now we hook it into CRI protocol because it's the easiest way to do. And to cover all of those, we need to hook into deep place like tasks inside containerd. But here it get conflict on the design principles. So one of the design principles containerd has what those fat clients like Docker or CTR waveform the spec of a container, and we don't expect what containerd will change it somehow. So there is some design conflict. What we need somebody who knows with deep detail to say yes or no.
I see. Yeah, because otherwise you have to re-implement it in all the different plugins, basically, containerd plugins.
It's not a problem of implementing that, but it's just which place need to do something, because. Well, another example, Ed proposed to create this patch for CDI injection in, Ed, was it CTR, right?
Yes, it was CTR.
And one of the reviewers said like, okay, well, good. So let's have parsing it's on the CTR side. But the thing is what CTR might be talking to containerd over the network. Or Docker daemon can do the same. It can talk to containerd over the network.
You just change the socket.
And you simply don't have access to those files what CDI has prepared, like in this predefined location.
Right. Yeah.
So this kind of underwater stones.
Yeah. Yeah, it would only be able to operate on the machine that actually was hosting the socket.
Exactly. Yes.
Yeah. Okay. Yep.
So how would you like to go through this? Because so what I
don't
did
think we need
was
can we just look at
the API actual API.
just look at the actual
yeah, that's what I was thinking. That is so. This is how the top level API looks like. Just a second. Maybe
there's a way to say view this file.
Yeah, I will dig it out from here.
Or you can just click on your branch and we can just look at it, not in the diff. Yeah.
Okay, let's do that. It's easier. So this is the one. So basically, this is now adjusted according to Ivan's wishes. So he wanted to do it so that there is a basic set of functionality which is directly visible on the registry. And those are basically these very few functions that you mostly need. So you need to do refresh. And then check basically whether there were any errors during the refresh and inject devices. So I think this inject is the number one most important because that's what majority of so that's what the runtime needs to do. If you want to do this on the client side, that's what the client needs to do. And all the other functionality has been hidden behind these extra interfaces, because those are mostly if you try to do something special. So I mean, that depends on what really you are doing. So for instance, if you try to spit out, I think CDI specs, then you might need those. And this reflects now that. So we have a few functions and that's it. So one to acquire basically the registry. So basically get the registry, which will on demand initialize it and load the specs for you.
And the registry is basically the pull everything in from the file system where all the files.
Yeah, yes, it will scan. So you can give it some options. So you can override the basic set of directories. So where it looks for CDI files, but if you are fine, so for instance, in our implementation, we didn't do that. So neither Ed need to do it nor me, because we are keeping the CDIs in the stock places. But if you want, you can do that for some reason.
Well, actually, I did it in the plugin. So plugin has like this option. So I'm just not using it, but so it can be pointed to like any set of directories. So not just one.
Yeah. Yes. So that's, and then we have the injection, which is, so that's also pretty simple. So you give it a OCI spec, give it a number of devices, and it will try to inject those. And then it returns an error if something fails. And if it couldn't resolve some of the devices, it also returns those explicitly that were unresolved.
So this is the API that either the NRI plugin or Edge changes to containerd would consume and then call out to.
Yes. Yeah. So basically, somehow you figure out what are these that you need to inject, and then you ask the CDI library to do it for you, and then it will do it for you and let you know if it failed. And that's basically, there is nothing. Then this is, so this list devices, this is another one. This is actually for, because there are two ways. So this is exposed here for the, let's inject all devices to a container. So it can be done in two ways. Either you emit, if you want, you can emit basically an entry called all, or whatever you want to call it, which lists all the devices that need to be injected, or you can just list the devices, pick those that you want, and then inject all of those. And that's it. So all the other functions are now hidden basically behind these extra interfaces. There are things like, for instance, so this is the.
Can you say the thing about? Can you say the thing about all again? Because I always pictured.
Okay.
I think we talked about this in a previous meeting that. If you wanted all, then that would have to be its own spec.
Yes. So in the initial implementation was actually, I took out a lot of functionality. The initial implementation had also this kind of functionality that you could, instead of giving a device, so you could give a pattern. And then why I added that originally, so when I heard about this NVIDIA's need for injecting all devices, so I was thinking that, okay, instead of always having to generate what the all means, you could basically ask it that, hey, inject for me nvidia.com/GPU =*. And then it will do everything for you. But I took that out now, so it's not in there. But
the main reason I'm thinking about it is I'm thinking about it in the context of our multi-instance GPU stuff, and all means something different whether you have multi-instance GPUs enabled or disabled. And so I'm just thinking if it's somehow baked in what all means, that won't quite work.
It's not. It's not baked in.
Yeah. It's not anymore. Yeah.
No. So and then even then it was not. So then it was working so that, I mean, star, because it was using file path glob patterns, and those are not valid device names. So if you were having a device called all and then you requested that, then it was also doing that. But all this matching has been taken out because it's very easy to do it on the. So if you are using this library, then you can build that with a few lines of code on top of this. It doesn't need to be provided by the library. And that is what is this CDI.
So this is kind of the minimal set of things you need to do. And that's why you've got list all, because if you want to actually get all of them and do the equivalent of your nvidia.com
exactly.
then you can.
Yes, so that you can do the matching. So I try to take out more, so really all the functionality that can be easily implemented on top of this.
Yeah, that makes sense.
So I took out also this resolving when there is this hack that the path contains basically a reference to a device. So it's not needed. I took also, so we only have inject. So refresh, inject, and check for errors. And basically that's it. So that's the basic interface. Everything else, which is for debugging, so for these kind of things that I can use here for checking that basically how does it look like if I want to inject this.
Mm-hmm.
So that's.
And refresh just means reread from disk.
Yes.
And otherwise it's just holding everything in memory.
Yes.
And what is the get errors exactly?
It's a get error. So this whole thing works now so that if you get errors when you refresh, it doesn't mean that it completely renders your full CDI database, basically, or this registry unusable. So for instance, let's say that you have an NVIDIA and some Intel CDI devices, and something goes wrong. So there is a corrupted Intel file. It doesn't mean that after that you should not be able to inject NVIDIA devices into a container. So basically, because of that, this whole thing works that when you do the refresh, it will not stop on the first error. It tries to go as far as it can get. And then it returns a registry which is in the shape where it is, but you need to know that did anything go wrong, because so this is something
I guess,
that was
why
another
why
thing.
do you need to call get errors separately, I guess, instead of just returning the map?
It returns the error. It does it.
I mean, from refresh.
Yeah, it returns also that.
Okay, I only see one error, not a map of errors from refresh. That's why I'm asking.
Yeah, so here it is so that you can get it spec bypass spec file. That's very difficult to do with a single error. So if you want to point out that
No, I
which
understand
file
why
is,
you have a map of errors. I'm just wondering why you have a separate call for get errors and you don't just return that map string error directly from the refresh call.
I think that's mostly for a sort of minimal interface. That usually most of I think the most common case is that if something goes wrong, then you either decide that you ignore it or you decide that, okay, now you abort the operation. And that's basically, so you are not really interested in that.
So
What was the error?
So it's optimizing for the common case of that error
Yes.
when you
Yes.
call refresh.
Yes. That was one design principle. The other design principle was not to build in policies. So built-in mechanisms that the client can decide how to react. So the client can say that, hey, if there is a registry error, I always abort. But that should be the client, so the CDI library's client's decision, in my opinion, and not baked into the library itself. That, hey, we will always force the user to fail if there is any error. That's not the. So this is old X11. Separate mechanism for policies, and design the mechanism so that any policy can build on top of those as the user wishes. So those were the design principles here. That's why I have this, so that the basic interface is fairly minimal. But for some things, for instance, these get errors, if you are interested in that, what are the exact files, and you want to point out for some reason that what is the file which has syntactic errors, for instance, then this is the one that you can use to do that.
Yeah.
But normally, I think it's not really needed. So then usually you are already doing something special if you need this. And that was Evan's one wish, that let's hide that from the basic interface and let's have a sort of.
But have a way to.
Yeah. So I did that.
Gentlemen, I need to drop.
Yep,
Nice discussion.
Yeah.
Thank you.
Yeah, I'm glad I finally got to read the NRI stuff and get my head more deep into this, because it makes it all a bit easier to talk about.
Yeah, definitely.
Yeah. Good. Okay. Talk to you guys soon.
Okay.
Bye-bye.
And if I don't talk to you before the holidays, have a great holiday, everyone.
Okay.
By the way, that's a question. So the next scheduled is 28th of December, and I think majority of the people out.
I won't be here. Yeah.
So I would propose we cancel it.
Yeah.
Okay.
Sounds
Okay.
Good.
All right. Talk
Bye,
to
guys.
you when in
Okay.
New Year.
Talk to you later. Bye.
Bye.